Note to self, wear your square root watch next week.
All right, here we go. Section 5, we're solving radical equations. You've certainly done this in Algebra 1 before, solving equations with square roots. Now we're going to extend that to cube roots, fourth roots, fifth roots. My caution, when solving equations with radicals or exponents, you may come up with a solution that does not make the original equation true. We've talked about this before. That would be an extraneous solution. So you may produce extra solutions if you do things like square both sides of the equation. So in the end, always check that your solutions are correct by plugging them back in. So let's look at how we would approach solving equations with cube roots in them or fourth roots or something like that. Well, whenever I see a radical in the equation, my goal would be to get that by itself. So think about if I just said, let's solve something like this. You'd probably start by saying, okay, well, I should subtract negative 25 from each side and then divide by negative 16. You'd want to do the same thing here. So to get that cube root by itself, I'm going to subtract 25 from each side. I would be left then with negative 16 times the cube root of h plus 1 equals negative 32. Next step, that negative 16 is not under the cube root, so I want to get rid of that. Since I'm multiplying by negative 16, to get rid of it, I'm going to divide each side by negative 16. Then I'd have the cube root of h plus 1 equals 2. Now to get rid of the cube root, I would just want to cube each side. So just like to get rid of the square root, I would square each side. To get rid of the cube root, I would cube each side. Now keep in mind what's happening here. This will become important later. The cube root is really like the 1/3 power. So to undo the cube root or the 1/3 power, I would just raise it to the 3rd power. And note that if I have two exponents here and multiply them together, a 3rd times 3 is just 1. So then you'd have h plus 1 to the 1st power, or just h plus 1. Okay, so that's what's happening. These are going to undo each other, the cube root and the cube. You should be left with h plus 1 equals 2 times 2 times 2, which is 8. So h ends up being 7. Certainly you can check this, so go back to the beginning, plug it in. You'd have the cube root of 7 plus 1, or the cube root of 8, which is 2. And 25 minus 16 times 2, or 25 minus 32, would indeed give you negative 7. So the left side of the equation equals the right. If you look to the next example, I have a 4th root of x, and then here actually I have a 4th root of x. There's a negative 7 of them. So these are like terms. It would be like saying if I had an x and a negative 7x, I'd want to get them on the same side of the equation. So same thing here. I'm just going to subtract the 4th root of x from each side of the equal sign. So these are going to go away. Then I'd have negative 4 equals, well, this is really like negative 1 4th root of x. So negative 7 4th roots of x minus another 4th root of x would give you negative 8 4th roots of x. Now again, I want to get the radical by itself, so that negative 8 is not under the radical sign. If you divide each side by negative 8, you should end up with 1/2 equals the 4th root of x. And to undo the 4th root, or the 1/4 power, I would want to raise this to the 4th power. What I do to the right side of the equation, I should do to the left. Cancel, cancel. And now I have on the left side a half times a half times a half times a half, or you could think of it as 1 to the 4th would be 1. 2 to the 4th would be 16. And that should be your answer. If you plug this back in, the left side of the equation would equal negative 3.5. the right side of the equation should also equal negative 3.5. So this is the one number that makes the equation true. So using those examples, why don't you give these two examples a try? Pause the video at this time. So the problem on the left, hopefully you divided by 4 first, so get rid of anything that's not under the radical sign. That square root of 2x minus 3 then would have to equal negative 3 to make the equation true. And then maybe you thought at this point, okay, well, to undo the square root, I should square each side. So square root undoes the square, and you'd just be left with what's under the radical. Negative 3 squared would be 9. And then maybe you added 7 and said x should equal 8. Now, if you checked your answer by substituting in 8 for x, you'd end up getting something like this. 12 equals negative 12. And certainly, right side should be negative 12. Does 12 equal negative 12? No way. Something's gone wrong here. So if we retrace our steps, perhaps you caught it. It'd be right back to this line here. Are there any numbers where I can take the square root of them and get out a negative? No, I mean the square root of 9 would be 3. The square root of negative 9 would give you an imaginary number. So actually at this point you could just stop, cut off the rest of the problem and say no real solutions. So there's no value for x that would make this equation true. Second example, get the radical by itself. So subtract 19 from each side, which would have produced this. Divide by 4. Can I take the fifth root to get a negative 1? Yes, I can. So if my index is odd, certainly I can take the fifth root and get out a negative. So from here I can proceed to undo the fifth root, or the 1/5 power. I'd raise this to the 5th power. Those would cancel. You'd be left with y minus 3 equals negative 1. And then the last step, add 3, and you should get out 2 for your answer. If you plug it back in and check, that would make the left side equal the right. Also, a side note on solving, notice that back at this point, I can't just add 3 to each side because that's attached, it's under the radical sign. So I need to get rid of the radical first, then I can go ahead and free up that 3. Now let's look at just a couple examples where we're solving equations with exponents. So maybe I don't have that radical sign in, but I have the exponent. Same idea, so this is all in the numerator. To get rid of dividing by 2, multiply each side by 2. Those terms would cancel. My whole goal is to get this x cubed by itself. So work through the problem. Subtract 4, I get 8. Once I get the x cubed by itself, at this point, I could take the cube root. So to undo the cube, I could take the cube root. Now I also want to bring up, remember the cube root is like the 1/3 power. So an alternate approach, which is really doing the same thing, would be to say, well, let's raise this to the 1/3 power. Now, why do I want to do that? Well, 3 times a third, if I have an exponent to an exponent, I would multiply those together. 3 to the third to the 1/3 would just be, x to the third to the 1/3 would just be x to the first power. 3 times a third is 1. So on the left side, I just have x, and then on the right side, what number to the third power is 8? That would be 2. You could go ahead and check your answer. If you plug this back in, the left side of the equation should equal the right side. Well, with this thought in mind, if you look at the second one, to get rid of the cube, I would cube root or raise it to the 1/3 power. So to get rid of the 1/5 power or the 5th root, eventually I'd want to raise this to the 5th power. So get rid of the 10, subtract 10 from each side. And to get rid of the 1/5 power, like we said, or the 5th root, I'm going to want to raise each side of the equation to the 5th power. 1/5 times 5 is just 1, so I have y to the 1st power, and -2 to the 5th would be -32. This is a pretty quick check. If you plug it back in, -32 to the 1/5 would be -2. -2 plus 10 is 8. So last examples, why don't you pause the video, think about how you would solve these, how you'd get rid of the -5th power and the -1/3 power on these equations. Okay, let's see what you did. So right now, this is by itself. I don't have to get rid of anything. But to get rid of the -5th power, I really want this to be y to the 1st power. So how would I get rid of the 5th power? Well, this was just the 5th power. I'd take the 5th root or raise it to the 1/5 power. So to get rid of the -5th power, I actually just want to raise this to the -1/5 power. Okay, well, why do I want to raise this to the -1/5 power? Well, if I take -5 times -1/5, notice that these are reciprocals. If I multiply a number by its reciprocal, I should end up getting 1. And that's what I want the exponent on y to be. So if I raise each side to the reciprocal of -5, now on the left side, multiply those, I'd get 1. So this is y to the 1st power, or just y, equals 243 to the -1/5 would be the same as 1 over 243 to the 1/5. So y is 1 over what number to the 5th power is 243? That would be 3. So y should be 1/3. And just a note, you can check these on your calculator pretty quickly too. If I take -1/3, or excuse me, 1/3 to the -5th power, I should get out 243. So last problem, add 2 to each side, divide by 32. 8 over 32 reduces to 1/4. Now, how do I get rid of the -1/3 power? Okay, so I want this to look like x to the 1st power. So if I raise this to the reciprocal, or the -3 over 1 power, I'm going to raise each side to the -3rd power. Well, now x would be raised to the, well, -1/3 times -3 is +1. So I have x to the 1st power, or just x, would equal, if I have a negative exponent, I'm going to flip my fraction and make that exponent positive. So x actually is going to be 64. If you check, plug this back into the equation, the left side should equal the right. So in the end, here's the big idea. To get rid of an exponent, raise the exponent to the reciprocal power. So if I have this, I could take the cube root, which would be the same as raising each side to the reciprocal of 3, or the 1/3 power. So x would be 4. If I have a fractional exponent, Let's make this -2. Same thing, and just raise it to the reciprocal. So the reciprocal of -1/4 would be -4. Now I have x to the first power would equal 1/2 to the 4th, or 1/16.